hit that follow button, because what you're about to hear might change the way you think about life itself. And trust me, the most mind-blowing part is still to come. This is the story of a creature that lives in a place so extreme, so deadly, that science once believed no living thing could ever survive there. Now imagine this. You're drifting in the pitch-black belly of the ocean, so deep that sunlight never reaches. There is no day, no night, no oxygen as we know it. And the pressure, it's strong enough to crush a metal submarine like a tin can. Suddenly, ahead in the darkness, a geyser erupts. Not with water, but with superheated liquid roaring out at 400 degrees Celsius, double the boiling point of water. No, it's not a volcano. It's real. It's alive. And it's hell on Earth. At the bottom of the sea, they call them hydrothermal vents. These black smokers form where tectonic plates pull apart, opening massive rifts in the ocean floor. Magma seeps up from beneath the Earth's crust, heating the surrounding water into a scorching soup of sulfur. Metals and deadly chemicals, erupting like underwater firefalls. And because of the immense pressure, this water doesn't boil. It stays liquid even at near-infernal temperatures. Yet here in this cauldron of death, where nothing should live, life flourishes. In 1977, when the submersible Alvin first discovered these deep-sea vents along the rift, scientists were speechless. They didn't find just a few microbes clinging to life. They found an entire ecosystem, teeming with giant tube worms, clams the size of footballs, strange crabs, shrimps, and alien-like species never seen before. No sunlight, no photosynthesis. But something else was feeding this explosion of life. At the heart of this mystery lives one of the most astonishing creatures ever found, Alvinella pompeiana, the Pompeii worm. This isn't just a worm, it's a survivor from the edge of oblivion. It's considered one of the most heat-tolerant animals on Earth. It thrives where temperatures flirt with 80 degrees Celsius, right at the rim of hydrothermal vents, where your skin would cook in seconds, where DNA unravels, and proteins fall apart. This worm calls home. Its back is coated in a fuzzy layer of symbiotic bacteria, like a living thermal shield. These bacteria feed on the vent's sulfur-rich chemicals through a process called chemosynthesis, similar to photosynthesis. But using chemical energy instead of sunlight, in return, the bacteria provide nourishment to the worm, keeping it alive in a place that should be lifeless. The Pompeii worm's body is a masterpiece of biological engineering. Its tail stays nestled in cold water, just a few degrees above freezing, while its head stretches into fluid hot enough to melt plastic. It lives, quite literally, between fire and ice. To survive this contrast, the worm's skin has evolved into a heat-tolerant armor, keeping its cells from breaking down. Its internal enzymes, the delicate proteins that drive life, are stable at temperatures that would destroy ours. This isn't science fiction, it's biochemical reality. And perhaps most intriguingly, the Pompeii worm doesn't roam. It anchors itself to vent walls, sticking its body out like a curious periscope, basking in the nutrient-rich flow of hydrothermal fluids. It doesn't have eyes, doesn't have a mouth, or a traditional digestive system. Instead, it's fed by the tiny chemical alchemists that live on its back. When scientists tried to bring Pompeii worms to the surface, they died within minutes. Change the pressure, they die. Change the temperature, they die. Even the slightest disturbance to their extreme environment is lethal. This fragility highlights a profound truth. Life may be able to thrive in hell, but it clings to an incredibly narrow window of balance. But that's just the beginning, because the Pompeii worm isn't alone. Every hydrothermal vent, every deep-sea trench, every boiling crack in the seabed is home to creatures just as bizarre, just as specialized. Some don't have blood, some breathe metal, some never move more than a few inches their entire lives. And some don't resemble any living thing we've ever known. The Pompeii worm might hold clues to the greatest question humanity has ever asked. How did life begin? Long before there was oxygen or plants or light, there may have been vents like these. Maybe the first life on Earth rose from places like this. Maybe it wasn't a sunny tide pool. Maybe it was the dark, boiling, sulfurous cauldron of the deep. And what's coming next will take your breath away. Because this story isn't just about survival, it's about evolution. intimacy, war, and even love, in the most alien environment imaginable. Thank you for staying with me this far. If the Pompeii worm already blew your mind, hit that follow, because we've only just opened the gates of this biological underworld. What lies ahead will stretch the limits of your imagination. As we leave behind the shadowy world of the Pompeii worm, don't be fooled into thinking we've reached the outer edge of what's possible. In truth, we've only cracked open the flesh chamber of a vast and eerie labyrinth. Because beyond the worm, there are others, stranger, more perplexing, and at times seemingly beyond our very concept of life. At depths of over 3,000 meters, another creature rises from the seabed like a pale, swaying banner in the toxic currents. The giant tube worm, Riftia pachyptala. These worms can reach over 2 meters in length. They attach themselves to the walls of hydrothermal vents, anchored to the very chimneys spewing liquid death. And here's the miracle. They have no mouths, no stomachs, no intestines, just a long, hollow body filled with bacteria. These bacteria, like the ones found on the Pompeii worm, convert hydrogen sulfide into energy through chemosynthesis. No hunting, no digestion. The worm is fed from within by an internal ecosystem, a biological partnership as intimate and efficient as any we know. The worm offers shelter and transport. The bacteria provide sustenance. One cannot live without the other. Quiet eternal contract signed not in ink, but in heat, sulfur, and survival. Shine a submersible's light around a hydrothermal vent, and you'll witness a scene that looks more like an alien metropolis than an earthly ecosystem. Thousands of tube worms sway like crimson flags. In between them, heavy-shelled clams nestle in cracks, and they're blinking in and out of the haze. Come the red spark shrimp, Remicorus exoculata. These blind shrimp don't see in the traditional sense. Instead, they've developed a light-sensitive patch on their backs, allowing them to sense faint thermal radiation from the vents. In a strange twist of biology, they see with their backs. But even stranger, their bodies are covered in a film of mucus that plays host to chemosynthetic bacteria. Each shrimp becomes a mobile garden, a chemical farm in motion. They scrape minerals from the rocks and feed their bacterial passengers. In return, those bacteria grow, multiply, and become the shrimp's next meal. No weapons, no speed, just chemistry and patience. A little farther from the vents where the heat fades into cold, you'll find other inhabitants. Some fish, though none like you've seen before. No swim bladders, gigantic saucer-like eyes, or no eyes at all. Skin like glass, organs that glow. Many of these fish don't even have names. Scientists mark them by date, location, or simply call them unidentified abyssal specimen. Some fish nest in hydrothermal crevices like burrows. They don't swim far, they don't chase. They wait for bacteria, shrimp, or whatever the currents bring. Some are parasites, some live in pairs. Bonded for life in a darkness where loneliness is default, and companionship is a rare biological treasure. Dig into the sediments beside the vents, and you'll discover a much smaller world, a microscopic kingdom pulsing with life at the limits of physics. Here dwell the hyperthermophiles, single-celled organisms that don't just tolerate extreme heat, they need it to survive. Species like Thermococcus, Pyrelobus fumari, and Methanopterus candeleri can reproduce in temperatures as high as 121 degrees Celsius. The same heat we use to sterilize surgical tools. How their enzymes' normally fragile molecules are locked into more rigid structures that don't unravel with heat. Their cell membranes contain ether-linked lipids instead of the ester types we use, allowing their bodies to stay intact even in scalding waters. In the dark, in silence, in water that would dissolve flesh. These ancient microbes divide, grow, and thrive, just as they've done for hundreds of millions of years. They don't need oxygen, they don't need light, they only need heat, and a slim chance. And so, in this sunless world, life doesn't burst forth with fireworks. It creeps, it seeps, it adapts. Every creature is a silent argument against what we thought was possible. They don't fight to live, they redefine what it means to live. You and I were born into light, breathe air, and eat food from plants or animals. But down here, in the quiet inferno of the ocean floor, each organism whispers a question into the abyss. If life can exist in darkness, in boiling poison, might it also exist on Europa, the ice-covered moon of Jupiter? Or beneath the frozen crust of Enceladus, Saturn's shimmering satellite? The answer may lie in a vent no wider than your hand, or on the back of a worm with no eyes. If you thought these creatures were strange, wait until you see what's next. Because next, we go deeper. 2 places with no vents, no heat, no obvious source of life at all, and yet life endures. Thank you for staying until the end of part 2. If your curiosity's still burning, hit follow, because we're only just beginning to unravel Earth's most alien biosphere. We've seen life blooming around hydrothermal vents, those volcanic chimneys that spew fire into the sea. But what if we told you, even without that fire, in the frozen plains of the abyssal seafloor, where there is no heat, no chemical fountains, no light, no oxygen-rich currents, life still exists? Let's descend deeper, past the chimneys, past the clams and the tube worms, past even the soft glow of vent-loving shrimp. Let's enter the abyssal plains, vast flat deserts of mud stretching for thousands of kilometers, silent and slow. This is the realm of zero light, near freezing temperatures, food so scarce it can take months for a single flake of organic debris to fall from the surface. And yet, even here, something moves. A ghostly octopus, white and translucent, glides across the seafloor with arms outstretched like a dancer in slow motion. It belongs to a group known as serrate octopods, sometimes called Dumbo octopuses, because of the ear-like fins that flap gently on the sides of their heads. They don't squirt ink. They don't dart through the water. Instead, they hover, floating like spirits, feeding on tiny crustaceans or worms buried in the mud. Unlike their shallow-water cousins, these octopuses live their entire lives in darkness. No moon, no stars, just black. And they don't need a cave to hide in, because in the abyss, everything is hidden. Crawling across the seafloor, we find brittle stars and sea cucumbers, animals that look more like fossils than living creatures. They feed on marine snow, the poetic name given to the slow rain of organic debris that falls from the upper ocean layers. Bits of dead plankton, fish scales, fecal pellets, all drifting down over weeks or months like an underwater snowfall. It's barely enough to sustain the simplest life. But these creatures don't need abundance. They've adapted to a life of waiting. Some bury into the mud and extend long feathery arms to catch falling particles. Others creep forward in slow motion, mouthparts scraping the seafloor for the faintest trace of nourishment. In this twilight realm, movement is rare. Silence is endless. But the hunger, the will to live, burns quietly in every cell. Among these mud-dwellers, we find one of the most enigmatic creatures on Earth, the deep-sea tripod fish. With elongated fins that resemble stilts, the tripod fish plants itself upright on the muddy floor using just 3 extended rays, 2 pelvic and 1 tail fin. It stands motionless, facing the current, holding its pectoral fins forward like antennae. These fins are hypersensitive, twitching with every passing vibration. When a small prey item, perhaps a drifting amphipod, brushes past, the fins snap shut, feeding the fish. It doesn't chase, it doesn't hunt, it waits. Sometimes for hours, sometimes for days. The tripod fish is blind. In the dark, eyes are useless. Instead it listens. Not with ears, but with nerves and patience. It has no mate in sight. Reproduction is rare, so it evolved the ability to reproduce both sexually and asexually. If it can't find a partner, it fertilizes itself. It is, in every sense, the embodiment of solitude and resilience. Now imagine drifting further out beyond the seafloor, into the water column, that massive volume of space between the seafloor and the surface. It might seem empty at first, but in truth, it's one of the most alien parts of Earth. Here, we meet creatures that flash with bioluminescence, not to light their way, but to communicate, to distract predators, or to lure in prey. Jellyfish with frilled bodies pulse in soft blue bursts. Tiny fish with lights under their eyes glow like haunted lanterns. Some release clouds of glowing fluid, like underwater fireworks, when threatened. Bioluminescence here isn't a bonus. It's survival. In the pitch dark, it's the only tool and the only weapon. And then there's the barrel-eye fish, a creature with a transparent head. Through its gelatinous dome, you can see its brain, its spine, and most hauntingly, its eyes, which point not forward but upward, like telescopes staring through the fish's own skull. It floats silently, wading beneath schools of jellyfish or plankton, looking upward for movement. When it detects prey, it tilts, accelerates, and strikes. This isn't a science fiction horror. It's real. It's living. Right now. Back down at the bottom, another creature creeps through the silence. The hadal amphipod, a shrimp-like scavenger that thrives in the deepest ocean trenches, like the Mariana Trench over 10,000 meters down. That's deeper than Mount Everest is tall. Pressure here is over 1,000 times the surface level. The water is barely above freezing. There is no light. And yet these tiny crustaceans swarm around fallen carcasses. Whales, squids, even trash that's made its way down. They strip the dead to the bone. They eat plastic. They digest metal-laced sediment. Their stomachs contain compounds that would kill most life forms. They are the ocean's undertakers, and they are unafraid of death, because down here, death is everywhere, and life feeds on it. So why does all this matter? Because for centuries we believed that life required warmth, light, oxygen, comfort. But these creatures prove otherwise. They show us that life, in its purest form, is not tied to luxury. It is tied to possibility, to persistence. When we look for life on other worlds, on icy moons, under the crust of Mars, in the acid clouds of Venus, we look for water, for chemistry, for heat. But perhaps the real lesson lies here, in the cold, silent plains of Earth's own ocean, where life doesn't just survive the impossible, it chooses it. And in the next part, we'll follow a whale's fall to the bottom of the sea and witness how one death gives rise to decades of life. A whale dies. Maybe it was old age, maybe illness, or a long, slow fight with starvation in the warming seas. Whatever the reason, its final breath escapes in silence. Its body floats, suspended for a time in the water column like a fading memory. And then, gravity takes hold. The descent begins. For hours, maybe days, it falls. A blue-gray titan, once the beating heart of the open ocean, now becoming part of the deep. It spirals slowly through darkness, deeper than any diver has swum, deeper than any sunlight can touch. And then, impact. The whale carcass lands on the seabed with a soundless thud, sending a fine cloud of silt into the still waters. It will never move again, but that's not the end. It's the beginning. Within hours, the first arrivals appear. Tiny amphipods, shrimp-like scavengers, come in swarms. They chew into the skin, the eyes, the soft tissue, like underwater vultures. Their numbers swell into the thousands, picking clean the outer layers within days. Next come the hagfish, long, eel-like jawless creatures that burrow into the carcass. They twist and knot their bodies to tear off chunks of flesh. Their mouths are circular, filled with rasping plates instead of teeth. They enter the whale from every opening, mouth, eyes, wounds, or new holes they create themselves. It's not beautiful, but it is necessary. Then the sleeper sharks arrive, slow-moving, ghostly predators of the abyss. Ancient fish feed slowly, cautiously, but with weight and patience. They do not fight the scavengers. There is enough for all, because in this desert of the deep, a whale's fall is a feast from the gods. Weeks pass. The flesh is gone. Only bone remains, a rib cage like the frame of a sunken ship. But the banquet is far from over. Now begins the second act of this great marine drama, the sulfophilic stage. This is where the true alchemy begins. Bacteria, invisible but legion, descend upon the oily bones. Whale skeletons are rich in lipids, trapped deep in the marrow. As the bacteria digest the fat, they release hydrogen sulfide, the same gas that powers hydrothermal vent communities. It creates a chemical halo around the bones, and it summons new life. Tube worms begin to sprout from the sediment. Clams nestle among the vertebrae. Mussels bloom like dark flowers. These organisms don't eat meat. They feed on the sulfur, made available by the bacterial bloom, through chemosynthesis, just like the life around black smokers. What was once a single animal becomes an ecosystem. And then come the creatures that specialize in death. stacks worms. They are beautiful and terrifying. Often called zombie worms, they have no mouth, no stomach, no eyes. Instead, the females, yes, only the females bore into the bones with acid and extend root-like tissues into the marrow. Their bodies sway like red feathers above the bones, while their roots siphon nutrients below. Inside their tissues, bacteria do the real work, breaking down the lipids into digestible forms. Once again, symbiosis rules this realm. Host and microbe, survivor and transformer. The males, they're microscopic, they don't eat. They live their entire lives inside the bodies of the females, hundreds of them, doing one job only, supplying sperm. In the darkness of the deep, evolution chooses function over fairness, and life continues. For months, even years, the whale fall remains. It becomes a landmark, a nursery, a battlefield, a final gift. Researchers have observed that a single whale fall can support more than 400 species, many of them found nowhere else on Earth. A floating city that collapsed, only to seed a new one on the seafloor. And then, eventually, even the bones are gone, dissolved, eaten, colonized. What remains is invisible. But the energy, the nutrients, the life that came from death is now part of countless creatures. Some have swum away, some still linger. Some have died, feeding others in turn. The whale is not gone, it has changed form. In the deep ocean, death is not an end. It is an invitation, a transformation.
Oh.
A pulse of life that echoes for years across the most barren corners of the planet. Above, we bury our dead in quiet earth. But in the ocean's heart, the dead feed kingdoms. And as we begin to understand this silent cycle, we must ask, what else have we missed beneath these waves? What other miracles have been swallowed by darkness never to rise? In the next part, we journey into the trenches, the deepest cracks in the Earth's crust, to explore creatures that live under pressures that should destroy every molecule they're made of. We've traveled far. From the fiery mouths of hydrothermal vents to the icy plains of the abyss, we've followed the descent of a whale into darkness, watched flesh dissolve and kingdoms rise from bone. We've drifted with transparent fish, with light-bearing jelly, with self-fertilizing hermits and bone-boring worms. But now, let us rise. Not to the surface, not yet, but into the twilight, where the deep sea breathes in rhythms invisible to human eyes. Here we find a phenomenon so vast, so constant, and yet so secret, that it might be the largest migration on Earth, and almost no one has ever seen it. Every night as darkness falls on the ocean surface, something extraordinary happens. From the depths, sometimes hundreds of meters below, billions of creatures begin to rise. Tiny zooplankton, shrimp, lanternfish, squid, jellyfish, all moving upwards in a slow, shimmering wave. This is called the diel vertical migration, and it is by biomass, the greatest movement of life on the planet. They ascend under cover of night to feed on plankton blooming near the surface, and before dawn, they retreat again into the safety of the deep. Why? Because in the twilight, light means death. To rise while the sun is high is to invite the eyes of predators, birds, fish, whales. But in the dark, the ocean belongs to the bold and the patient. It's an ancient dance, silent, predictable, and essential. And as they rise and fall, they cycle nutrients between the surface and the deep. They move carbon. They seed the ocean with nitrogen. They feed the creatures above and below. Each tiny swimmer in this vertical parade plays a role. Each flick of a tail helps regulate our climate. And yet, most of these creatures are no longer than your thumb. They glow not because they want to be seen, but because the deep demands it. Bioluminescence is their language, their camouflage, their weapon. A slow flash in the dark may say, "I'm dangerous," or "I am here," or simply, "Don't come closer." And now, slowly we surface, not just from the water, but from the journey. Because this has never been a story just about creatures. It's been a story about limits, about what life can endure, and where it chooses to go. We often think of the deep sea as a kind of final frontier, but it's not. It's the first frontier. It's a place where life may have begun, where hydrothermal vents, rich in minerals and energy, could have nurtured the first cells. where chemistry became complexity, where the earliest whispers of life found shelter in the dark, and even now, those whispers continue. In every Pompeii worm that clings to boiling rock, in every snailfish that glides through a trench deeper than Everest is tall, in every unseen shrimp that rises each night to greet the stars and sinks before dawn. We who live under the sun forget what the ocean carries. We forget that most of our planet is not land, not forest, it's not sky, it is sea. And most of that sea is deep. There are places on Earth we have mapped more poorly than the surface of Mars. There are lives that have come and gone in silence, without a name, without a witness, but they mattered. They changed the chemistry of the water. They fed giants. They held on, because that is what life does. It holds on. Even in boiling blackness. Even under 1,100 atmospheres of pressure. Even without eyes. Even without light. It adapts. It remembers. It refuses to vanish. So when we speak of life in the ocean, on Earth, or beyond, we must speak with humility. Not as masters, but as fellow passengers. Maybe, just maybe, when we look up at the stars and ask, are we alone? The deep ocean whispers back, you never were. Thank you for joining me on this journey. From fire to silence, from death to rebirth, from the crushing trenches to the great vertical migration of the twilight zone. If this voyage stirred something in you, wonder, awe, or a quiet question, hit follow, because the next great mystery might already be swimming beneath your feet. This is the end of the deep, but not the end of the story.